Okay, so I'm going to go over the solutions to homework 6 / homework 7. We don't really know what its name is, but it's homework 6 right now in my directory. So we have the rpn.c file. That's the only file that we're working with. I'm going to open it up. Okay, so this program is a mostly complete program implementing the RPN evaluation algorithm, essentially. So it's a reverse Polish notation calculator that handles a limited number of operators. So the first thing we need to do is we need to fill in our empty function stack push, stack pop, and new node. Stack push and stack pop should be easy because we went over them in stack push and new node should be easy because we essentially did them in class. New node is just the simple function that creates a new node for the linked list, and stack push is our linked list insert algorithm because we're using a linked list to represent our stack in this program. Alright, stack pop is the only new function here. So let's do that. Let's go down and let's start out with new node because that's the first thing that's going to need to happen. I'm going to need a node underscore t pointer. I'm going to call this temp and let's set it equal to null. Alright, so we're going to start it out at null. Now let's try to allocate some memory to it. So I'm going to do this inside of an if statement. If temp equals, I'm going to set it equal to a node underscore t pointer malloc the size of node underscore t. If that whole expression is equal to null. So essentially I'm saying if temp is still equal to null after I have ran malloc. Alright, that means that we ran out of memory. Fprintf std error, and I'm going to print out error malloc failed. This should never happen, most likely, on modern systems, so we don't really need to worry about it, but this is still like good practice. Alright, and if that happens, let's just exit out of the whole program. Alright, that's probably really bad. Alright, so now temp has some memory, the proper amount of memory, and now I just need to fill in its value and its next pointer. So temp arrow value is going to equal the parameter value that we passed to this function. Alright, and then temp arrow next is going to equal null, okay, because we don't know where it's going to point. That's up to whoever calls the function. Alright, and at the very end we just simply return temp. Alright, so that's a new node function. Now let's do stack push. So this is essentially just linked list insert. Okay, so I'm definitely going to want to make a new node no matter what. So I'm going to say node underscore t pointer n, we're just going to call it n for node, is equal to new node. I'm going to pass in the value. There we go. So I'm using the function I just called as a subroutine in stack push. I create the new node, and the idea is I want head to equal the new node, but I want the new node's next value to equal head. Okay, so I'm going to say n arrow next is equal to head, and then I want to say head equals n. There we go. That is the stack push function. That's all we need. Alright, that's pretty cool. Now we want to do stack pop. That's the last one. Alright, so let's go ahead and we're going to first let's just check to see if the stack is empty. If not head, if not head, that means the stack is empty because it's not pointing anywhere. So oh, you know what, let's go back up to stack push. I just made a mistake that a lot of you may have made, right? Head is being passed in as a double pointer. That's because we want to be able to change head from within the function. Alright, so I need to put asterisk head on everywhere where I use it. Okay, that's dereferencing that pointer. And if you, yeah, so that's good. So now let's go back to stack pop. We're going to do the same thing here. So if not star head, that doesn't look great, does it? Because we've got these two unary operators right next to each other. It'll probably evaluate correctly, but I still don't really like the way it looks. So I'm going to use a strategy here, node t pointer. I'm going to call this RH for like return head, okay? And I'm going to set it equal to star head, okay? So this is essentially like a local copy of head that I can use. So now everywhere where I would use head, I'm going to use RH instead, okay? If that's not true, then that means my list is empty, and I should have an error message, fprintf std error, pop from empty lists. Alright, and I could try to return something sophisticated, that means error here, but I'm not going to, because this algorithm, if the input is correct, it should never have an empty stack until the last thing is popped. So we should never be popping from an empty stack with this algorithm. So I'm just going to exit when this happens, because if my assumption is that the input is incorrect. Okay, the input's incorrect if this happens, so the program should end. Okay, so the next thing that I want to do is, okay, at the very bottom of this function, so this is the bottom right now, I want to store my copy of head back in the proper memory position. So I'm going to have star head equals RH. That's going to be at the bottom, okay? So I'm doing that now so I don't forget. So I'm copying head here. I'm copying head on line 76. And then I am editing that copy. And then at the end, I'm putting it back in the memory address that was passed in. That way, the changes take effect in the calling function. Okay. So now I want to pop from the list, and this function should return the value that I pop. Okay. So and I also want to free the memory because I use malloc to create the node. I'm going to want to free that node, or I'll have a memory leak in my program. Okay. So I want to the step is going to be head RH equals RH arrow next. Okay, that's actually the step. That's going to pop from the top, right? But after I do that, I can't reach that memory. I can't reach the original head, and I can't reach that head's value. So I need to store a copy of the original head. Temp, I'm going to call it node underscore t pointer temp equals RH. So I'm storing another copy of head in temp. That way, at the bottom, I can free temp. All right. So here's another dilemma. I want to return temp's value, okay? And at the end, I want to return temp's value, but I can't because I freed it. So I also need to store my return value in a variable. That way I can return it, all right? Because after I freed it, I can't return it from temp arrow value. So now at the bottom, I can just return RV. So that's the whole function, I believe. That should work just fine. We'll come back to it if it doesn't, but it should work just fine. Now, let's go up. Number 2, we want the ability to perform division via the slash operator. Okay, so that's pretty simple. We just need to go down here, and we need to add the case for the slash symbol, right? Just like we have for here. So I want to actually just copy this and put a slash here. Okay, so now I want to handle division. So what should I push on the stack? A divided by B. I want to print out a sort of sophisticated error message if I'm dividing by 0, because that's something I can't do, right? So I'm going to say if B is equal to 0, I am going to do an fprintf std error, and I'm going to put error, and I'm going to say, actually, I want to, we'll see, I might have to change that, but I'm going to division by 0, new line. That's good for right now. And if that happens, we should actually, let's just go ahead and exit the program, because we ran into a fatal flaw in the input. Alright, there we go. So that handles that case. Now we want to also make number 3 says add the ability to perform exponentiation via the caret operator. So let's go down here. I'm going to copy this one more time. And I'm going to look for the caret operator in this case. So this is wrong, right? This is wrong because the caret operator in C is not exponentiation. It is XOR, bitwise XOR. So this is wrong. Okay, this doesn't work. So we could do one of two things. We can write our own power function that multiplies a number by a power, okay, or performs exponentiation, or we can just use the math library's power function. I didn't include math up here. Pound include math.h, okay. So we just need to compile with -lm if we do that. And I'm going to use pow, which is defined in the math library, of a comma b. So b. There we go. Alright, so that handles the power function. Cool. That should be the whole program now. So let's go ahead and save, make, and then I'm going to do the hand in check. So I'm going to go back and into my home directory, hand in -c cs202. I have to do that, remember, because I am in my Gaulish account, which is, so if you don't have a 202 CS202 in the name of your account, you have to do -c CS202 and --hw check and homework 6. Let's see if I did it. Oh, look at that. Mine's wrong. Okay. I wrote error division by 0, and it should have been encountered division by 0. So I wouldn't have counted off for this if this happened when I was grading, because your program isn't wrong. It's just not the same output as mine, right? But if I want the homework check to go smoothly, I'm going to go down here and I'm going to fix that. Encountered division by 0. Make -k. Make -b is actually what we want. No, okay, what's going on? Oh, I'm not in the right directory. So make -c homework 6. There we go. All right. So now I want to do the hand in check one more time, and now I passed 6 out of 6 checks. That's the whole program. All right. Bye.